Today's stream. The time is now 12 p.m. Central Time. And I am your host, Dr. Matthew Richardson, and this is another episode of CosmoQuest Astro Office Hours. So, as you can see, I have some programming stuff in the back. So, today is definitely going to be me trying to get some research done. But before getting into all of that, let me go ahead and verify that I'm actually streaming. So, go through the usual steps of opening up a Chrome browser window and navigating to Twitch and making sure that you guys can hear and see me and that I can read your comments. Let's see, all right. So Twitch is reporting that CosmoQuest is still offline. OBS software, what are you saying? OBS software is saying that we're recording. We're live. For at least now a minute and about 15 seconds. Oh, there we go. Twitch is now reporting the same. Let's refresh the page. And there appears to be 7 people here, so welcome, guys. Or at least it was saying 7 a minute ago. I'm going to go ahead and pop out the chat. Hey, Jetlander. So I'm going to admit to you guys, today I'm kind of like in full out programming mode. So I'm going to really try my best to be able to pay attention to comments and stuff like that, while also making sure that I let you guys know what I'm doing. Hey, Tom Ben Scotter. Let's see who's all here. Hi, Cosmic Lettuce. Hi, Electrical Skateboard. Hi, Jetlander 8. Hi, Larry of the G Cloud. Hi, Michael T. Mayer. And hi, Peter Q 1978. Welcome to today's stream, guys. And thank you for joining. But yeah, today is really going to be like me trying to get this incidence angle analysis like completed. So in my last stream, I was talking about the fact that I was making some corrections to our database. And what prompted the corrections was the fact that the data that I was getting from the database for the incidence angle analysis, I realized wasn't completely correct. And so I've made my corrections. I've updated the database, at least the copy of the database that I currently have. And I've rerun my simulation. Thank you for letting me borrow it, Peter. I like it. It's really nice. But yeah, I updated the database and I reran my simulation and basically it looked like I was getting the exact same results. There were a few minor changes that were positive, but it wasn't what I expected. And so what I'm going to do today is focus on how my how my algorithm is comparing images. So one of the key things I want to be able to do is see if 2 images overlap. And so what I'm going to end up doing today is I'm going to write up a portion of the code that will allow me to basically see what the bounding regions are doing for a single image, or 2 images that are supposed to overlap. Hey, Guido. All right. So in the process of me doing this, I end up realizing that I could get a little bit of a speed up with my program by moving some stuff around. Prime example is that I'm within this for loop here. So let me make sure that you guys can see what I'm seeing. Yeah, it's showing. I'm within this for loop here, where the variable that changes is variable j. this variable I right next to it, so the for j equals I is the variable for the outer for loop. So this is actually a double for loop. If I could avoid double for loops, I would, but in this case, I can't. So I have this outer for loop, and then I have nested within it this inner for loop, where the index variable for the outer for loop is I, and the index variable for the inner for loop is j. And I quickly realized that, just now actually, that everything I'm defining here within the inner for loop is completely dependent upon my upon the index variable I. So I can actually move all this stuff outside because it's doing this every single time it runs. Um, it iterates through the inner for loop, and really the values don't change. So I'm gonna move this out just to make sure that it all looks right. Yeah, it looks right to me. Okay, then I can stop here. I mean, this in itself is not really going to help me solve my problem, but it's just going to allow the program to run slightly faster. It's fairly quick for what I needed to do, but I mean... Oh wait, I want that there. Alright. So that should be good, and I probably should write a comment. What is this? Image 1 data. I'll just put that for right now. I might change it later. I should change it later so it could be more descriptive, but this will work. Alright, so one of the things I've changed so far that will be important for being able to plot these boxes that represent the images is I'm adding the two variables image1 height and image1 width to be collected as important information with another variable I've defined. Let's see. Alright, that's good. And I'll explain what I'm doing here in just a minute. Let's get comments really fast. Make sure I'm not missing any of your comments or... Oh, I'm sorry to hear that, Guido. Hi, Adam. Yeah, I wish I had more control over the resolution that you guys can choose, but from my understanding, I think I've done as much as I possibly can. Alright. So that's good, that's good. I also added those same two variables for image 2. And now I need to be able to make sure that these variables can be, in a sense, recorded within my vector that collects all of this information for the two images. So in the bottom, in the terminal screen that you're seeing down here, this vector here, OL images dot push back and so forth. Basically, OL images is collecting all the information that I'm getting, all the important information that I get for the two images. And so the important information is being actually shown down here within the terminal window at the bottom. I think my face might be covering up some of the information, but the key thing is that it gives an ID for, so basically this is going to be a pair of images that are supposed to overlap, and the information that I've retained would be some sort of like ID to indicate which pair I'm referring to that overlap. Um, the image, both image IDs, so the images themselves have their very own unique IDs, as well as I'm also capturing the what would be considered the origin for a single image. So in order for me to be able to locate craters within the image, within a single image, those craters reference or know where the origin is for that image. And for each image, the origin is the upper left-hand corner. Um, but as far as my coordinate system, the internal coordinate system for my algorithm is concerned, each corner of an image knows how to backtrack its way to the origin of the coordinate system I've defined within the algorithm. So I've established a series of vectors to be able to locate craters relative to the coordinate system I've established within the algorithm. And then there's some other information here also, like the pixel resolution, the area of the image. So that is the physical area that the image is imaging on the lunar surface. What other information? And also the bounding region of the area that's supposed to overlap. And right now I'm adding 4 more bits of information that will allow me to be able to make these plots that will show exactly how the images are overlapping. Hey GN Nintendo. I hope that's correct. So Guido, you think if I stream at 480p that might be a possible solution? G works for me. But nevertheless, welcome to the stream, G. uh, if you broadcast in 4, yeah, I don't know if I can change it now, and I don't know if I should change it now. But I'll look more into this though. I think I lowered the resolution before. I think I lowered it to 720p, and that's the reason why. All right, well, let me get back to this. So let me go ahead and insert this information. I want it to go here. But I gotta change a few things somewhere else though. I have to change this. All right, so overlap images is a class that I've created, and basically it stores all the important information for 2 images that overlap one another. And like I said earlier, the 4 bits information that I'm now adding to the overlapped images class will be the height and width of each image. Because in order to be able to define, for example, the box that represents the image, and as of right now, I know at least the coordinate for the origin or for one of the corners of the image. So if I have that along with the width and height of the image, and I can define the box that would represent the image in my coordinate system. The voodoo magic of kitchen Wi-Fi is working. Yes, you are so right. So this is not particle physics. That's actually a really good question. But no, this isn't particle physics. So my background is related to particle physics, which is the reason why I ended up learning how to use root. But today I'm actually using this. So yeah, today I'm actually using this to be able to doing analysis I'm doing with the project that I'm working on called CosmoQuest. And so the actual analysis, the analysis itself is, wow, my words are really bad today. But the analysis itself is basically seeing how incidence angle affects how our citizen scientists, that is, the general public, everyday people, um, are marking crater positions within the images that we have of the lunar surface. Yep, that's it. Exactly what Guido states there. Ah, cool. Honestly, when I first started learning how to use Root, no one in my department knew how to use it because my department was the astronomy department. Yeah, I definitely agree with you, G. All right, so let me go ahead and put this in here now. Thanks, Guido and Peter, for going ahead and providing that information. But yeah, for anyone who's new here, definitely if you get the chance, check out CosmoQuest.org as well as the Weekly Space Hangout crew. The information has been provided um, by both Guido and by Peter. So thanks, guys. All right, so to insert this information, I need to know exactly where I want to put it. They will be doubles. I think I was here last. All right, so I want them to be able to go directly after. Well, as far as the width and height of image 1, I want it to go directly after these two variables, image 1 x origin and image 1 y origin. So let's just do this. So copy this. This will be good. This will work. Comma. Given that I've added them there, I have to make sure that. So let's just do image 1. Image 1. This is going to be width. Save it. I can copy this and paste it after these variables. There we go. And now I need to change this to image 2 and image 2. But actually, let me give you an example of why I think there's an issue as to how the how my algorithm is actually stating that two images are overlapping. So in the terminal window down here below, this first line, which here, corresponds to two images that should overlap one another. Those images being this image here, M1150084550LE underscore 2 underscore 33, where the information from M to E, the M115 all the way to the E, is the actual image ID. The number that comes after that, the number 2, corresponds to the scaling factor that we're using for this particular image. And well, not scaling factor, but the scale. It's the number that corresponds to what the current scale for the image. And the number 33 represents the slice number. So in this example, or for this case, I've taken image M1150084550LE and I've sliced it up multiple times. This particular image is the 33rd slice of that bigger image, which is M115 and so forth. And the number 2 corresponds to essentially how many pixels how many pixels, how many square pixels we've selected from the image. So to kind of make that all short or shorter, I've taken a really big image. Its image name is M115, so forth. I've selected a subsection of that image where the number 2 indicates exactly what the area, what the square pixel area of that subsection is. And it's the 33rd section that I've taken out of the image. So this particular subsection has been paired with another subsection, which is given by this ID. And so what I'm going to do is I'm going to go ahead and show you exactly what these images look like. So all of these sliced images are being stored online. So I will need a browser for this. I'm a postdoc now. But what happens after postdoc, I'm not entirely sure right now. but yes, I'm a postdoc right now. So I'm a postdoc that works at the Planetary Science Institute, even though my background is high energy astroparticle physics. And I work on the CosmoQuest project. And the CosmoQuest project specializes in facilitating online research projects that the general public can participate in. I was looking to get a browser open so that I can show you guys some stuff. So just give me one quick second while I do that. All right, we're going to go ahead and start up a new scene. But yeah, here we go. We'll add. So right now you guys can hear my voice, but you don't see anything. Just give me a quick second, and I will fix at least one of those problems. All right, let's minimize that. Put me back in the lower right-hand corner, and let's get a browser going. Alright guys, thank you for just bearing with me while I do this really quickly. Let's see, window capture, internet. That should work. And Safari. Alright, so going back to the first scene, what I'm going to do now is I'm going to pull up the information that's the information that will allow me to navigate to the link for these images. So, going back to my terminal, like I said earlier, all this information is being stored in a database. We currently use a MySQL database to store our information. And so to pull up the information for a given sliced image, all I have to do, and here's the actual, like, some of the output from the database I'm showing now. That's really small to see. It's cool. So let's go ahead and pull up the information for this particular image or slice. And so I'm now highlighting the link. And we're now going to go ahead and go over to Google or to this web browser and see what the image looks like. So that looks weird. It looks, there we go. All right. So this is the image, or at least one of the image from the pair that's supposed to overlap. So now what I'm going to go ahead and do is I'm going to pull up another tab. And this tab will end up eventually showing the second image that's paired with the first one, or that overlaps the first one. So let's go back to our MySQL browser, or our MySQL, excuse me, um, terminal window. And I need to quickly go back and grab that ID for that slice. Okay. I got the link. I can now go back to the other. I gotta keep remembering to keep switching the scenes, because... Alright, there we go. And this is the second image. And so, based off of the information that I'm getting from the actual ID for the sliced image, I know that this image that I'm currently seeing should be smaller than, or should be within, the image that I'm showing now. So this image, this entire image actually, should be somewhere within this image. However, I quite literally spent a very, very long time yesterday trying to find this image within this image. And I had no luck whatsoever. Now, of course, I mean, I can do zooming in, because that's what I would need to do, because this image is much, much smaller than this image. If I'm not mistaken, this image should be equivalent to, what was that, 1,000. So let me go back to my terminal window. It should be the equivalent of 1,350 pixels by 1,350 pixels. That's the current image I'm showing. This image should be 4,050 pixels by 4,050 pixels. So this image is much bigger. And so I should expect to find this entire image within this image. But like I said, I couldn't find it, which is the reason why I want to be able to plot, or at least create something that will allow me to see how the two images should overlap. And so my plan is to go ahead and use the code that I was showing earlier, specifically the root package. It's been created by particle physicists at CERN, to be able to produce a plot that will allow me to plot a box that represents image 1, and then plot a second box that represents image 2, and see exactly how the two plots, the two boxes overlap one another. I want to make sure I'm not missing. Ryan Invade, what's up? So in MySQL add -g. Oh, okay. Exactly, Adam. I agree with you. A match does not quickly jump out at all with this. But, I mean, it might be possible. Maybe I'm not looking at it correctly from the right orientation. I don't know, but it might be there. It's kind of difficult just to see it, you know, by just looking. Even if I made this smaller, let's see if I can do that actually. So, let's see if this works. I'm going to open up another tab. I'm going to copy this. I'm going to paste. I'm going to take this out. Let's see what you guys can see right now. This isn't going to work actually. I wanted to see if I can somehow make it such that you can see both images at the same time, but it looks like that's not going to work. Oh, I got my PhD from Vanderbilt University. Sorry guys, I'm now looking back at the comments trying to catch up with everything. Working from the crib today, huh? That is me every day. I promise one of these days I'm gonna come to Edwardsville and just hang out for for like a week or so and do some work from there. All right. So let me go ahead and get back to what I was doing. So let's go ahead and switch scenes back. Okay. So I think the last thing I was doing was I was modifying, or at least I needed to modify a class because I'm adding information to this particular variable or oh, all right. So I think I end up adding 4 more variables to this vector, which is basically initializing this class variable overlapped images with all this information. But I need to modify the class itself to be able to know that it needs to take that information as well. So I need to go back here. Well, first, actually, let me do this. So 1, 2, 3, 4, 5. So 6 and 7. So variables 6 and 7 that I'm passing to this class are, excuse me, are doubles. 1, 2, 3, 4, 5. So I would need to add them here. A double and a double. And I would need to add 2 more doubles somewhere else. Let's go back and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the 15th and the 16th variable is where I need to add them. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here. And that should do it for now, at least for the declaration. So now I need to modify the actual definition. So let's go back here. I can quickly do this. Pulling up another one. And so this particular tab that I've opened up is the source code for the class overlapped images. So I'll scroll up, and the information needs to go after image 1 Y origin. So I'm adding 2 double variables. And I think I called them what was it? Image 1 height was first, and image 1 width was the next thing. Note, guys, I am by no means a programmer. So well, what I mean to say is that I haven't had any formal training with programming. Most of the stuff that I've picked up, is just, everything I've been doing with my research or with research projects in the past. So you guys might end up seeing something that's kind of like, what's the best way to put it? Probably not the most efficient way to do something. And if you do see it, by all means tell me, because I want to be able to make sure that my code is efficient. But generally the things I worry about is to make sure that the code actually works the way in which it should work. And that it's, depending on what I'm doing, it's not too slow. But luckily, though, I have my fellow colleagues, both Ryan and Joe here, so they can let me know if I'm doing something wrong. And I think Ryan caught something earlier. I apologize for my ignorance, Ryan, but you said at dash G. What does that do for me exactly? Does it like change the formatting or something like that? Let's see. So I'm gonna need to add some more variables here. So here I can say, oops, not capitalize. Image one, and this will be width. It's equal to that. Let's scroll up and let's go ahead and get that. And copy and paste this. Actually, the height was first. And this now needs to be height too. Capitalize. You know, when I first started coding, I started coding with IDL. And in IDL, variables, the capitalized version of a variable is equivalent to its lowercase version. So there's no like differentiation between a capital X and a lowercase x as far as variables are concerned. Whereas with C and C++, it is important. So okay, thank you. Yes, you're so right, Guido. I enjoy your distractions, guys. So Fortran is the same. So basically, it's not case sensitive. Yeah, that stuff. It was kind of it was weird to me when I first transitioned from IDL to C. One of the postdocs at the time was telling me that C is much faster, and I was like, okay, I'll learn C. Learned C and started to forget things about IDL. But in general, I mean, to be very honest, and I mean this is just my perspective. I'm pretty sure that others have different perspectives, but the key thing to retain whenever moving from one language to another is what's the word I'm looking for? I guess you'd want to be able to remember like the pseudocode, like exactly how do you go about um, doing a particular task. For example, I know that if I want to be able to search through an array, um, I probably wouldn't want to go do it, element at a time. I'd probably want to sort the array first, and then use something like a binary search or binary sorting algorithm. The pseudocode for the most part will be the same across languages. I think I could be wrong in saying that, but I think it would be the same across languages. The key thing that would be different though is probably the syntax that you use. All right. CERN code is awful. But like I said, this is just my own perspective. I'm just saying some stuff, what I think about coding. So whenever I might need to actually jump back and like look at some IDL, I probably won't remember, most of the different functions that are available with it, but in general, if I'm looking at the code, I can kind of figure out what the person's doing. All right, I'm kind of like losing my train of thought on what I'm doing here. All right, I'm looking to add this, definitely. Copy and paste. And let's add it also here as well. But change it to image 2. I'm realizing this is very difficult to do. To code while also trying to like maintain a conversation. I have the same problem whenever I'm playing chess. Someone will like kick off a conversation with me and I'm playing chess and I'm into the game and I just can't do it. I just can't do it. Even if I were to break away from the game or, you know, like coding for a little bit to actually like engage the person in the conversation, I've probably missed everything they've said while I was actually doing the playing chess or coding. Okay. I'm gonna take away my face for a little bit here because my nose is running. So I don't want you guys to see me like take my napkin here and there we go. I'm back. I'm sorry. What's wrong, Ryan? You said my bad, Matt. Sorry about that. Only reason why I said it because I might end up having to do it again. My nose is running a lot today, so I think I might be coming out with another cold. All right. Let me actually get back to getting this work done. All right, so image. I need to add these variables. Add them here. Image 1 height. Okay. Image 1 width goes in here somewhere. Add it here. Image 1 width. I can essentially just copy and paste and make the appropriate modifications. Image 2. Image 2 width. I think that should be good so far. I think I've gotten all the information I need to get in here. Let's see if I compile it and what happens. So I'm going to go to the terminal window or tab, excuse me, that has my make file in it. So it's clear and let's run make. It's compiling. It's compiling. All right, that's not too bad. So a few errors. Oh, okay. This is completely unrelated to what I just showed you guys, but it is related to some other stuff I was doing prior to actually starting the stream. So I can ignore the warning, but the errors I have to correct. So basically, the errors are due to plot.cc. Right. So I didn't save this apparently because it would have showed up. But basically, those errors are basically saying that on the right hand side of my equation that I have there, those equations, I didn't have information. But the key things I was trying to be able to grab from a variable of type overlapped images would be the x and y origin and the width and height to be able to create the box. So I've actually already started writing up the section of my algorithm that will be able to plot the overlap regions. That is, basically just make these boxes and plot them on top of one another. That is, if they actually overlap. So I can be able to see exactly how they overlap and then compare that to the images that I was showing you earlier online, that's offered online, available online. Okay, that's cool. You know what? I need to also be able to retrieve that information. So I need to add some functions. A get function. So get image one height. I don't know why I always do this, but I always want to make sure that things are in alphabetical order. It makes it easier later on for me to be able to find stuff. Let's see, and also I need to create 3 more functions to retrieve the information. So this will have to be width. This is get image 2 height and get image 2 width. I'm realizing that this font is really small, so let's make that bigger. All right. And then I need to come up with their definitions. Which one? Area. So here. Sorry guys for being so quiet right now. Every now and then I'm actually going back and looking at comments. All right. That's that. And I can copy and paste this and just make the correct modifications. So image 1 width is right here. Or get image 1 width. And then there was also so as you guys can tell, I do a lot of copy and pasting because it's just faster that way. Right here. Get image 2 height. here, I need to put get image to width. All right, so that should be good. I think I'm going to still end up running into a problem with this, so I'm just going to comment out this information. And save it. Let's run make again and see what happens.